Okay, folks, welcome back to the Virtual Residency Workshop 2021. This is Wednesday, June 9th, so right in the middle, smack dab in the middle of the workshop. This is the early afternoon session, deciding which technologies to adopt and when. It's a panel. Our moderator is Kiran Matra, and I'm going to turn the show over to Kiran. You go right ahead.
Hi, good afternoon, everyone. The topic is very interesting for all of us, especially I'm in a IT side, and even I'm interested in hearing from all of you, all the panelists. So we have the panelists. Where's the list? I'm sorry. I have too many screens. Our panelists today are Aaron, Sean, Mahmood, Kirsten, and Prasad. Myself, I'm Kiran Matre. I'm with Harvard's Central Administration IT Department, and I serve the dual purpose of Senior DevOps Engineer as well as the Scrum Master. Aaron, to you.
Yeah, hi, I'm Aaron Bergstrom. I'm the Advanced Cyber Infrastructure Manager at the University of North Dakota, where I direct the activities of our high-performance computing and systems, as well as coordinate some big data and AI activities. So are we going to jump to my slides, or are we just going to do quick introductions first?
Quick introductions first.
Okay, yeah. And then I run a recently established AI and virtual reality lab at UND.
Sean.
Hello, everyone. My name is Sean Cleveland. I'm with the University of Hawaii. I am a cyber infrastructure research scientist in the Information Technology Services group. I do a lot of work on developing science gateways to support researchers on some of our big projects at UH. I do a lot of HPC facilitation, and I'm also a co-PI on the TAPIS grant, which is an API middleware framework for building science gateways on top of.
Mahmood.
Hi everyone, Mahmoud Shad here. I work at FAS Research Computing Department at Harvard University. My research software engineering team works with Research Computing Department to design, to build software and data services to accelerate cutting-edge research at Harvard. And we also worked towards submitting grants to different funding agencies to create infrastructure that can apply for multiple groups. Thank you.
Prasad.
Hi everyone, I'm Prasad Madhyamaki. I work at Florida State University Research Computing Center as an HPC application specialist. So I do like most of the install application support as well as general HPC support here for about 7 years now.
Kirsten.
Hello, everyone. Thank you, Henry and Kiran, for organizing the program overall, but also then this specific panel. I'm Carson Siller from the Research Computing Group at the University of Virginia, where I'm leading the user services team of computational scientists. So our user services group directly interfaces with researchers and students. We teach workshops, help them with HPC onboarding and tech support, code optimization, more in-depth consultation projects. We also handle community outreach activities and so on. In addition, we also have a team of engineers and solution architects that provide the infrastructure design of the compute platforms, the deployment, and as well as the maintenance. And we have an extra person for managing communications and marketing. And of course, last but not least, our director, Rick Downs. And that's really everything about me and our team.
Okay, our first panelist, Aaron, please go ahead.
Sure. Yeah. So a couple years ago, UND the UND, I had a conversation with UND libraries about setting up a virtual reality lab inside the main library at UND. The new digital librarian wanted to change sort of the atmosphere of the library. She wanted to give it she wanted to give it a reason for students that not only come to the library besides just checking out books, but also wanted to sort of move it into the next century, I guess. And so our main IT on campus moved into the library, and then the high performance computing or the computational research center was also invited to move into the library. And we now have our offices are now located over there, or will be at the end of this month. But also we set up a fairly nice virtual reality lab, or what we're calling the artificial intelligence and virtual reality lab. So the space was constructed using funding from the library remodel. So the entire library was remodeled over the last 2 years, and so that's where the majority of the construction costs came in. And then I went to my boss at the time, the vice president of research, and said, "Hey, I'm getting this free space. Can you give me some money to outfit it with hardware?" And he responded with, "Yes, but you have to use that funding to get new grant funding." In other words, I'll let you keep spending money on virtual reality and AI in the context of virtual reality if you bring in grant dollars. And so we actually brought in our first $4 million Department of Defense grant this year, which will be using mixed reality environments. And so can we go to the next slide? So I just want to talk a little bit about the differences between extended, virtual, mixed, and augmented reality. So extended reality is sort of the overarching term that's for 3D or 2 to 3D graphics that that provide imagery with the physical world, right? So we have virtual reality, which is pretty much video game-like environments that use 3D graphics. They don't have to be stereoscopic, but generally these days, when people refer to virtual reality, they refer to some sort of stereoscopic 3D display. And by stereoscopic, I mean the computer renders a separate image for each eye, so that to mimic the real-world parallax that you have inside real world. Mixed reality is similar, except for that it has real world imagery mixed with the 3D graphics or 2D graphics imagery. So if we can go to the next slide. So here we have 2 different versions of virtual reality headsets. The one on the left is virtual reality, and it basically wraps around your eyes, and you basically get the entire viewing area is basically a video game 3D environment. Whereas the headset on the right has not only the virtual headset or basically the 3D stereoscopic rendering environment, but it also has cameras in the front for video pass through, so you can actually see your real world environment. And at the same time, it has LiDAR capabilities too, so it can actually show you a 3D representation of your hands out in front of you if you hold them out in front of the camera system. So these headsets are Vario headsets. They're sort of state of the art. They're new VR3 and XR3. The difference in cost between those is about $2,000. So the one on the left costs $3,000, one right costs $5,000. And the one on the right is the one we're going to be using for our Department of Defense project. All right, if we go to the next slide, please. So augmented reality is similar to mixed reality, except for that the real world is sort of the emphasis, and the 3D graphics part is is basically designed to augment, your physical environment. So the case on the left, we have heads-up displays where you just got 2D graphics displayed in front of you. And then in the case on the right, we have a virtual product tryout.
I couldn't hear what you said.
Oh, my phone's talking to me. Sorry about that. And so the product on the right is virtual product tryouts. Where you're trying out you've seen commercials on TV where you can put the paint on your walls at your house, or you can put furniture in your room, or you can try on virtual glasses. So go ahead, go to the next slide. So when it comes to what's between augmented and virtual reality, it's really kind of a sliding scale. You're mixing real world with the virtual, with the 3D rendered, and each has their places. I would say, and you get into the hardcore mixed reality stuff that we're going to be doing for the Department of Defense project. We'll have a green screen up. We'll have ROTC students wearing mixed reality headsets, and they will see their physical bodies and the equipment that they physically have on them in front of them. But we'll have a green screen out in the distance, and we'll have the 3D rendered environment rendered out. So their physical body will be between them and what they see in the virtual reality. That's probably one of your more hardcore mixed realities. But all that's a sliding scale down to augmented reality, where you have educational type applications, where where the students, in this case, we see them just looking at 3D anatomy, either through a tablet or through some enhanced phone applications. And so that's just wanted to go over those differences between virtual, mixed, and augmented, and then we can pitch it to the next person.
Okay, thanks, Aaron. Yeah, so again, I'm Sean Cleveland. I'll be talking about other interfaces and emerging technologies. So one of the first things I'll hit is sort of some of the things to look at when we're looking at adoption for some of these emerging things. So initially we kind of look at, what's the cost on some of these things. Sometimes we get free stuff from vendors, like recently Dell and Intel are giving us some one API equipment for a couple researchers. And so there's no cost associated with that. As far as equipment goes, we have to figure out, where do we host it? How do we support it? So there's still some costs on that side of things. So we look at those. We're working on grant funded projects, or MRIs, CC star things that are related to some of these emerging things. Are we having to replace existing infrastructure, things that are disappearing with new interfaces? So for example, Google Drive for Education is going to be something that is a big thing for our researchers that leverage it heavily. How are we going to replace that with some comparable interface to do that? Researcher PI driven needs assessment. Are we partnering with the PIs on something? Is it scoped, to the individuals or the lab department? Campus wide, is it going to be a multi-institutional thing? And then another thing we look at, since we're doing research and we're publishing research, is can we publish on this? Will this be a catalyst for additional research and funding? So that's also part of the sustainability stuff that we look at on some of these emerging things. Are there other funding models that we can look at this? Can we make it service model things so we can recoup some of the costs and continue to support these things into the future? Are these emerging things topics that are heavily of interest to our institution, as well as on the national and state stage, so that there'll be additional investments from those groups that we can leverage? And then also we kind of look at what's our staffing experience and things looking like there. So we can go to the next slide. As we talk about interfaces, Science Gateways is a big way that we add additional interfaces into some of our resources, and then tie existing resources on the national scale into our offerings here. So I think maybe Science Gateways has probably been brought up in some of the other sessions here, but again, if you're not familiar, these Science Gateways, usually they're kind of a web accessible interface that ties science and engineering communities. They're shared data, software, computing services, and things kind of all in one place to lower barriers to entry for folks that don't do a lot of HPC or other types of computing. Collaborative environments. Some of the things to do is bringing in some of the visualization components in there with the data and compute, being able to track provenance, also being able to disseminate out the data, and then also supporting fair data standards, kind of all in one package is some of the things we look at for Science Gateway. So you see this little diagram here. This is the Hawaii Climate Data Portal is something that we're going to be rolling out, and we're looking at supporting a bunch of different infrastructure tied into sort of a single Science Gateway interface to tie into our Mana HPC at UH, our storage through sort of like own cloud interfaces, using the TAPIS framework to tie a bunch of stuff together, VMs on Jetstream, looking at Sage 3 for visualization, Binder, a whole bunch of these different, NSF and other funded projects that are cyber infrastructure that we sort of tie together with some of these new interfaces here. So if we can go on to the next slide. Some of the other emerging things that we see down the pipe and that we're looking at supporting is, data and event-driven computation things. We're seeing stuff coming from sensor streaming, IoT, and edge. And so one of the projects I work on, the TAPIS project, is aimed at looking at, how can we support this with new interfaces and APIs. Serverless compute is something with, Lambda function as a service. So having, AI functions as a service for Sage 3 visualizations. So as people work with those things, being able to kick those things off. The cloud was just kind of the last session, but looking at cloud integration things. So Jetstream 2 is going to be coming online in the fall. So we're a regional partner with that. So, we're trying to figure out how we're going to leverage virtual machines and containers and that sort of stuff for our things going forward, and looking at commercial cloud offerings for, how do we tie all that stuff in? And then finally, security things are emerging. So multi-factor auth is something that's been out there, hasn't been adopted by every resource. So that's something that is, sort of a technology that, how do you adopt that with your resource, and then tie in things like OAuth and side tokens. Because as in the last week we see with vCenter and ransomware attacks, like we can't afford not to look at how we adopt emerging security technologies into our infrastructures as well. So with that, I will pass it on.
Mehmet, you're next. Please go ahead.
This is Parsad, right?
Oh,
Maybe I put it in the wrong. Oh.
okay. I guess Prasad, do you mind going ahead?
Sure. Hello, everyone. So I'm Prasad Madhumage from Florida State University. Next slide. So we were looking at FSU. We were looking for a way to attract new, like non-traditional HPC users, so to speak. Like by non-traditional, I mean like not people outside of computer science, physics, chemistry, engineering. So for example, we have users coming from like education, psychology departments. So the main issue with, even some of the traditional like disciplines, people from the traditional disciplines, is the Linux, having to learn Linux before they, they get to use HPC. So I've personally had some users coming to me with like a printout of Linux commands, like step 1 do this, step 2 do that, and the workflow breaks due to new software upgrades or some reason, so they are kind of lost. So we wanted to give like better user experience. So I heard about Open on Demand a couple of years ago in this Henry's workshop. Thank you, Henry. And then I did some testing, and we decided to adopt Open on Demand last year. So it is a HPC portal gateway, so to speak. So people can, click their way through submitting jobs, um, check the job status, and like GUI type of jobs like MATLAB, RStudio, that kind of things, without having to type any like Linux commands or no job submit scripts or anything. So next slide, please. So the main feature is that they don't need like third-party software for any of these. Like for example, file access, like they can upload relatively small, like depending on their internet connection, of course, like less than a gig size file, I would say. Uploading, downloading, editing, files they can do just by clicking. And yeah, if they want, they can have a shell access without party or anything. Also job management, submitting jobs without ever having to like create a submit script. Or we use Slurm. So Slurm job, I mean, they have several sample scripts to choose from, and I mean, they have to like edit, like do minor editing, like depending on the job they want to run, but they don't have to like do too many like editing on the submit scripts, and also run interactive jobs. I think that's the main feature. That, for example, MATLAB or RStudio, visit those things are really slow. If you like, especially if you were like connecting from home with a not so fast internet connection. So it's a big, I mean, uh, yeah, it's a big help with Open on Demand because I think Kirsten is talking about Jupyter Notebook next. So Jupyter Notebook get a really, I mean, people are complaining that it's impossible to run Jupyter Notebook through SSH with an SSH connection, but it's really like fast through Open on Demand. So we had really positive like user, So next slide, please. So I'm going to show you like few screenshots. So the one on the top left is the home directory, like what they see their home directory. You can see that they can just click on the directories and go to their files and open them, edit them, and upload, download without any like WinSCP or any other software or typing SCP, commands. On the top right is a MATLAB job submit script. So they can choose which version of MATLAB and how many cores, how many nodes, and just submit the job. So they were actually submitting a Slurm job, but it's like under this behind the scene. Bottom left is the job. Like if they want to create like a custom job, they can do it through the examples here. And the bottom right is the like shell access. That's all I want to talk about the Open on Demand.
Kirsten, you're next. Go ahead.
All
please.
right, thank you. So I'll briefly introduce two technologies that change a bit of how research can use shared compute platforms, namely Jupyter Lab and software containers. And really the motivation was driven by the user community, the researchers who asked for these tools, but also for our own sake in terms of managing the software stack and offering programming environments. So in that sense, I'm going to explain a little bit what these two tools are. So Jupyter Lab is a web-based interactive development environment for Jupyter notebooks, code, and data. And it supports many different programming languages. In fact, I think today it's more than 100 different that are supported. It's very popular in data science, scientific computing, and machine learning, but it's also very popular with those who are just starting to program. So therefore, it can also be a very valuable, low barrier teaching tool. Containers are really to package application code on executable and all its dependencies that are needed to run into one, what's called an image. They provide lightweight virtualization at the operating system level. And this is opposed to the virtualization that you have in of the hardware that you see in a virtual machine. Containers are also offer portability of application across different environments and compute platforms. And again, that's like a nice tool to have so that researchers could take their analysis tool and software stack to another HPC platform if they wanted to. So on that note, several container projects are actually specifically targeted at HPC environments. The next slide, please. So I don't want to go into too many technical details, but just instead introduce an example of how these two different pieces, Jupyter Lab and containers, kind of came together for us as part of a seamless solution as a work environment on an HPC cluster. So Prasad already introduced Open on Demand. Thank you for that. And we also are running Open on Demand. And we had an easy way to plug in Jupyter Lab as a new interactive web app application. So as shown in the screenshot on the left, the researcher can log into Open on Demand, and then they specify the resources, the compute resources that they need, like the node partition, maybe CPU core numbers, memory, access to specific devices like a GPU. And once they submit that request, this will be sent to a resource manager. In our case, we're using Slurm. And the user's Jupyter Lab instance then spins up in a web browser tab that is backed by the specific compute node resources. So as you can see then in the center screenshot here on this slide, the Jupyter Lab session provides a very simple file manager, a notebook pane where the user can then interactively develop code and execute it. The notebook also collects the outputs, even plots, and researchers can even include all the documentation here together in one file as this notebook. Now, the real kicker is that Jupyter Lab allows the user to switch between different programming environments, and these are also referred to as kernels here. And as I mentioned, at the moment, there are more than hundreds of these different kernels for different programming languages. And you see these individual kernel options that the user can use as little tiles toward the bottom of the screenshot. Now, this kind of ties now into the integration with containers, because the compartmentalization and self-containment of these kernels is where the software containers really shine. They are, specifically conceived to do exactly the isolation of environments and providing all the dependencies to run your code. So there are, as I mentioned, several different container frameworks. I'm not going into all the details, but we picked for our purposes Singularity, and like the other ones, it can also deal directly with Docker container images, which is obviously a very a popular thing. So at UVA, we're using these Docker images, convert them to Singularity container runtimes on the fly, or save them in a cached repository. And then we have essentially now a portfolio of these containers where each container may back a very specific kernel. For example, one container backs the TensorFlow kernel, another one PyTorch, and so on. So in addition to the individual container backed kernels, there are also kernels that can be provided by user-specified conda environments. This is, again, a very nice feature where the users can augment and become self-sufficient in driving their own kernel options. And as the third option, we also offer the kernel backing by conventional software modules. So with this, I'm going to wrap up this technical overview and really just want to emphasize we are using Jupyter Lab integrated in Open on Demand very easily, and we're using the containers on the back ends to really establish an easier access portal for the researchers with less need to learn command line options. And with that, I'm just going to leave it here and give it back to Kieran. But I think there should be a lot of ample opportunity to discuss general lessons learned related to the technology, as well as support models required.
Thank you, Kirsten. I'll just ask the same questions that was asked for Open on Demand. Are you hosting the Jupyter Lab environment? And are there the SaaS providers available or hosting available?
So the Jupyter Lab instance, actually we are running Open on Demand as in a VM. And then Jupyter Lab itself, we implementing actually as a module. And so when, in the screen, if you see at the bottom, when essentially a compute node starts the session, we're just spinning up, a single instance that is user specific, that brings up the web browser portal. And then the user will, through the shared file system, will then have access to either their custom environments or a few sets of Singularity backed containers that we provide.
Oh, thank you. More on to you next.
Thank
Sorry
you.
for the confusion before.
Oh no, I think I placed it in the wrong order. Thank you, everyone. I enjoyed listening to you guys and the technology. We are using some of them in FAS Research Computing. This is largest research computing department at Harvard. We have different teams helping to accelerate research and computational research. And my team, research software engineering, as I said, helps to develop software and data services to help with research. And one of the topics that is growing, I mean, the need is growing over time, is we are dealing with big data. We want the infrastructure to host this data in order so other users can access and run analysis. Like Parsad mentioned, open on demand. We use open on demand to access our computational resources, and we are looking into adding different tools to enable people to work with their data regardless of their size. Can you go to the next slide? So I'm going to highlight one of the projects. This is one of the big projects that we are doing. Few developers, data engineers, research software engineers, and me we are involved in this project. So we are working with a research group, and they have around 30 to 50, including the external users, and they study environmental public research, and they have data from different resources. They have data from census, from climate, different climate data, and also health data, which are Medicare and Medicaid. And the data is growing. Every day there are new data sources that researchers want to study, and they use, let's say, open on demand to access data and use different apps or Python and different apps to run analysis. But we want to have the infrastructure for them in order to streamline the data request and creating a user workflow so they can access the data. So this diagram shows the process as we are going from the raw data to the database, which is Postgres, and then running user requests in a streamlined fashion. So we use Airflow to put those data processing pipelines and use CWL to specify different steps in the pipeline and distinguish different step in the pipeline. If one step fails, you can just restart that step. So we go from raw data using Python processing pipeline developed in our department, and we clean the data, or the ETL process loads the data to database. And we also use Apache Superset to run visualization over the database for PI or the data admin. If you want to check any information, it gives you a nice visualization of the data. Users request data, and we created like a workflow. It is a still ongoing project, which I'll show you different component in the next slide. So we had to build the infrastructure, and the new infrastructure includes a level 3 based on the data security defined at Harvard. We have to create a level 3 because of the Medicare and Medicaid. And then we are also working on a FISMA environment with collaboration with different departments to have this. So this slide shows different system diagrams. As you can see in the VM, we are having database, superset, this Nginx web server, and also the storage backend, Ceph storage, to handle this large need for the storage. And in the data pipeline, you can see the different pipelines for GridMed. These are like climate data, EPA, again, for climate data, census, and health data, Medicare and Medicaid. And in order to create this data platform, we have to also make sure that in the development phase, we are creating a system which is robust, which is sustainable, and which is reproducible. We can reproduce it. As you can see in the CI/CD part here, we are using Puppet and GitLab to create those CI/CDs, and also we are keeping all the configuration, most of the configuration in Puppet. If in case anything happened to the infrastructure, you can go and reproduce the same infrastructure. We underestimated the need it needs for infrastructure, but it is going in the right direction. I'm happy that it's getting together. And also for monitoring, for most of the research computing, we are using Elastic and Kibana. and also Grafana for monitoring services. And the last box shows the user workspace. As you can see, user sends the request, and then it goes through a streamlined process which extracts the data from database and packages in a, let's say, HDF5 format, which you can add metadata to data. And then users go to the Open on Demand and ask Slurm to assign them resources they need to run analysis on their data using Jupyter or R or any other resources. And of course, one issue comes with sharing this big data. One of the, can you go to the next slide? One of the issue we have when you're dealing with sharing active research data, if it comes in like terabytes, petabytes, like there are platforms you can share your published data. Like at Harvard, we have Dataverse. But if you are dealing with data sitting on cluster, terabyte, petabyte, we are using Globus. I'm sure most of you guys are familiar. We have a managed endpoint, and then you can have personal endpoint in different locations that users can access the endpoint and also share data with their collaborators. It has easy authentication process. I mean, users they don't need to open an account. They just log in with SSO using their Harvard key. And there is also, you can also write APIs using Python, right, to coordinate the data transfers between different places. And I would be happy to answer any question you have.
So let's open it for the discussion and questions. Everyone, please feel free to either put it in chat or unmute yourself. One of the question here is, can you talk about the installation of open on demand requirements? How easy and difficult it is to install?
Yeah, I can talk about that a little bit. So they offer to either build from source or RPMs. We use RPMs for like everything. So we choose the RPMs. So you can clone the repo. OSU, like Ohio Supercomputing Center, they have like create the repo with open on demand RPM. So you can just clone it and install the RPMs. And then the user guide is pretty good. So you can, follow the instructions and customize it. They provide like good customizability. You can change colors to change the text and like add logos or like do tweaks as you need. It's not hard. If you've done RPM install, it's just pretty straightforward. So anybody else have any comments?
So are you having the environment on-prem, or it's in cloud, or it's a hosted
It's
space?
on-prem. So we tested with an VM at first, but it's a small VM with like 2 gigs of RAM and I think 8 cores. So we noticed that it's a little bit too heavy. So we decided to install it on a bare metal node. But I know like several institutions who's running like pretty beefy VMs. I don't think it's a big deal. So you can either have a VM or on a bare metal hardware node, but it's on prem.
Kirsten, how about you guys? What type of platform are you using to host it?
Yeah, so we are also hosting it on-prem, in this case, a large VM. I don't know exactly what the memory specs are, but again, in this case, all the VM is doing is kind of the lightweight, shell commands and those things, but anything like JupyterLab itself will be immediately spawned through the scheduler on actually dedicated nodes, just like a job. That will be just kind of interactive. And that's actually has turned out to be an interesting support a question for us, because researchers, request the job and it's interactive, but then it may take a little while until the scheduler finds, places the job and the session spins up, and they may just let it sit idle for a while. So that's why for the actual JupyterLab sessions, we are restricting it to single nodes so that, you can't request, several nodes and, where for the most part, the system would be sitting idle. So that's one of the consideration.
Anyone else would like to chime in?
So I mean, we are kind of deciding whether to go on like a single node jobs. I mean, right now we have single node jobs, like you, Kirsten said, but we are trying to decide whether to open it up for like large, like multi-node jobs, because some users have requested that. Have you guys had any issues with that, or has anyone tested, on other HPCs?
So for us, I think, as I indicated a little bit, a lot of the researchers or students using JupyterLab, for example, are interested in machine learning. So they are usually doing, GPU loads, and there are more now. They're interested in maybe doing, multiple GPU devices at once. But our nodes have anywhere between 4 and 8 devices typically, which is still good enough to schedule them on a single node. But in principle, again, since it's through the Slurm scheduler, we could open it up to multiple nodes. But again, the risk is more like that. The sessions would be mostly idle. So what we typically do is encourage our researchers to do a small scale single node interactive session, and then convert, let's say, their Jupyter notebooks into standalone scripts that they can run non-interactively on maybe multiple nodes if that's what they need.
So one of the couple of questions are here is, how was the evaluation process? And I can add to that, what other products were considered along with Open on Demand and Jupyter? Is there any other competitive products or tools available, open source or commercial? Prasad, Kirsten, can you
So we
share some?
anything that's like currently supported. I mean, that's a big concern for us, something that's being developed, being supported. So that's a big plus on Open on Demand, because it was like still like funded and it's been developed. They released the Open on Demand 2.0 like a month ago, I think, last month. Yeah. So we haven't found like comparable like alternative to Open on Demand. I mean,
Yeah, I think our sentiment is similar, that we saw it's growing in popularity, and researchers may have even come across it at other places when they came to our university, and it seemed to be well supported. Our engineers, when they setting it up, they got I think good pointers by the Ohio supercomputing groups, that helping get it up and running. And for the interactive apps that we're launching through Open on Demand, so I mentioned JupyterLab. Clearly, that's been taking off out of the IPython projects, about a decade ago already, and then the other things that we're running through it, like our Studio server as a separate interactive app. I mean, those are all pretty robust, seemed like community projects that we feel comfortable with, to put them out there without being concerned that they just die off, anytime soon.
mm-hmm. Yeah, I mean, that's the problem with some of these community efforts. I mean, they start out good, and then you devote like you spend your resources, your time, and hardware resource, and then they wouldn't like support in couple of years, and then you have to find something new.
So how do you make the balance between being on the bleeding edge versus getting the stable environment? Or most of the users, it doesn't matter to them as long as something is working.
So is this a question for anyone in particular or open for the
Yeah,
whole?
just anyone. This is
Yeah, so
some
maybe
sort of,
some others would like to chime
yeah,
in
yeah.
since we
I'm just
talked a lot
asking
about Super Lab. Yep.
open-ended questions, not just
Mhm.
Jupyter Lab or on demand.
So I can speak for you, University of Hawaii. When we roll some of this stuff out, we kind of do a beta phase normally, and so we get a group of researchers who are interested in whatever the new features that will be enabled by whatever this new technology that we're going to be rolling out. So they're super interested in those things, and so we have honest conversations with them about what they can expect. That there's going to be some issues, and we'll actively be working with them, and they're kind of like guinea pigs in this exchange. And so we kind of roll things out in sort of a beta phase. And we did that with our open on demand for quite a while. And I think we just took down after about a year, we just took our beta message off the open on demand since everybody's using it at this point. And we say it's, not in beta. It was kind of like Google's Gmail was in beta forever. So we did that with our open on demand when we rolled it out. But that's what we do with some of the different services. We'll pick a small group and we'll see how things work out for them and get their feedback. And then we'll keep inviting more people until we roll it out to, our institution at large.
Mahmood, do you want to talk about it from the Harvard's perspective? I also work with the Harvard Central Admin, but we support the administrative technologies. So our focus becomes much more different from the regulatory and the user needs and the stability.
Yeah.
And having the good balance between the leading technology or bleeding technology and where we use them.
Yeah, I mean, understanding user need, can come from different sources. Like we have office hours, we have tickets. I mean, the ticketing system gives you a good history of what users need, and also we host town halls for different departments sometime and to listen to their needs. And also we design surveys, send it to our users who are using our clusters and different technologies. And compiling all those, we can come up with suggestions, and of course it depends on the budget and the other priorities. Like open on demand was a technology that we deployed like a few years ago, and that is really helping researchers who are not comfortable using the terminal or using the web service. For my team, I start with a smaller user, and if I can map the need for a larger group, and then I talk to directors and other people to see if we can. For example, this data platform I showed you, we noticed more groups are using, they need this. There is a need for a general like purpose data lake that different groups can use and access. And then we just share with the director and other people to see if there's enough interest to drive the project. But there's always a challenge in the funding, and we have to keep the balance. Yeah.
Aaron, anything from your side, since your project suppose you are working on the virtual reality, and those are some of that and AI are the bleeding technologies.
Yeah, what we've seen on campus is a lot of people interested in using virtual reality for things, but with limited expertise. The departments on campus who's had some expertise in that area or had the capacity or the capability of throwing money at the problem did that, right? So we have our atmospheric sciences, or College of Atmospheric Sciences. They started their own basically game development or virtual environment development lab with their own programmers. So engineering put together a VR lab, but there are quite a few other people on campus who want to do stuff, and so our central IT office was trying to pull something together. And I guess what came about for us is I actually, in a previous life, I was a computer visualization manager for another lab, another university. So I have a background in VR and 3D and all that kind of stuff. In fact, that's how I got involved in HPC to begin with, is we rendered a 3D stereoscopic movie on an HPC system. And that's sort of how I became HPC later on. What's the question again, exactly? I sort of lost track of my train of thought.
The question was in general, how do you find a balance and how do you decide
Oh,
the bleeding technology to use and
yeah, it's
how to
been
use
a
it?
little bit confusing, right? So in one sense, we designed our lab so that it was all rack mounted servers, and that has given us the freedom to do some creative things during COVID. We're currently using V100 cards to implement vGPUs, so we can do desktop, accelerated AI and graphics desktops out for training around the state of North Dakota. We're currently in the middle of deploying that. But that was an unforeseen thing, right? It was basically spun out of wanting to keep our hardware assets secure, so that we didn't want to have work. We wanted to have the lab open in the evenings so people could come in and use it, but not. But we were worried if we didn't have anybody there, we would have missing graphics cards the next day. So when it comes to cutting edge stuff, uh, the bad thing about VR is there's always a new VR headset coming out next month, and something. I mean, HPC sort of has the same problem, um, but the turnover rate on VR technology is basically every 6 months, and so we buy something and it quickly becomes out of date, right? And even though, and the problem is nobody really knew how to use the stuff to begin with, and then it's out of date, and now we have to buy new stuff, and so um, I started out buying hardware that faculty wanted to use, only to come to find out that they would buy their own off a research grant and not tell me. So they ended up not coming in and using it. We try to keep a level of at least a little bit of hardware that nobody else has, but this most recent DoD project, most of the hardware, the new VR technology for that, is coming from that grant. So there's a little bit of disconnect about the staff we have on hand, because a lot of people want to experiment with VR, but we don't have the staff to support everybody. There's a big overhead when it comes to developing the content. And if you live, and I'm sure in San Francisco, where there's VR, there's universities that teach that stuff. There's art schools that teach how to develop 3D and all that. It's easy to find content developers going to your college. In North Dakota, it's really hard to find somebody, if it's not in architecture, who knows how to use a 3D program to develop 3D content. So that's an issue as well.
Okay. Thank you, Aaron. Now, another question I have is, how do you deal with the university administration research priorities when you feel that their understanding of the technology required and cost is limited? In a sense, how do you handle when researcher or administrative, they want something, but they have no idea about the cost involved and the support involved, or what the technology they really need?
Yeah, so I guess that was kind of my question. So yeah, it sort of relates to the last thing I said about researchers coming to me asking for hardware, then acquiring it, and then come to find out they've gotten their own. and just the expectations, like, well, if you have that hardware, you must be able to show me how to use it within like a day, and then I'll have my research project going. I can't answer this question directly in the context of virtual reality, but indirectly, it's a process of building partnerships, right? So we built the partnership with the library, with the understanding that I had expertise in that area already, and then I had that basically, space lined up, which was, that space is not cheap, especially with the library remodel. Luckily for us, that's where the money was coming from, but that allowed me to talk to the vice president of research and say, look, we could have this nice asset that would be usable for research projects if I could get, several $100,000 of equipment with hardware. So I think.
I guess
Ahead,
that's
sorry.
not just for hardware, but for software too.
Software too. I think one of the things I'm working on now, though, the hardware and the software, that the funding for that sort of all came from the VPR's office. But one of the things I'm looking for now is trying to get funding for staff to be in the space to not only show, they have to learn how to use this hardware and software, but then they have to be there when the people show up at the VR lab to have something to do, right? To be able to have an expert there of some kind to at least get them started. But then when people don't show up, they have to have something to do too. They can't just be sitting there playing video games. So, we're looking at working with the library to do 3D digitization of some of the museum type objects that the library curates, right? I did see one question in the chat here a while back that said, does the library check out VR headsets? And it is our intent to do that. We had several headsets on checkout from the library for a while, but because of inventory, we had to bring them back. Sometime in the next 6 months, we plan on starting putting stuff back on checkout with the library so that somebody comes in at 7 o'clock at night and the library is open, they can check out a VR headset, head up to the VR activity space and interact with that VR experience. So that's one of the things that we partner with the library on, although we currently don't have that as an active checkout system.
Sean, Kirsten, any comment? Mahmood?
I think there are technologies that we know they are important, but what is most important is the user base, and you feel that this can be applied for larger user base. And to get that, you need to have a process. Another way is to look at other universities, like for example, Open on Demand was started right at Ohio Supercomputing Center. They started the project and also shared their experience. That helps also to bring to help with convincing in terms of the priorities. Sometimes users bring this technology they need, right? They ask for when several users are asking for technology, that makes it more priority. But I think the most important part for priority is what are the user base that currently are using. There are many technologies you can deploy, like GPU boxes, many GPU boxes, AI application. Some are looking for faster file system. Some are looking for more application software to be installed. Number of users, I think that's the most important part when it comes to priority and the need for the technology to be adopted.
Yeah, there are some nice comments in the chat regarding echoing the similar things.
Yeah, I think
Next question. Yeah, go ahead.
I was just going to add, I think I agree what was said here, as well as in the chat, in terms of, having the need to understand what the researchers are doing and what they need. And sometimes what we experience is even the administration or even the researchers say, we want this. And then one of the strategy is first to ask, what do you try to accomplish? Because maybe the technology that you picked out is really not what you need for your specific problem. And that sometimes can help to kind of, steer the conversation in a new direction. And of course, funding might be then still, if it's, capital intensive, might be still another problem. But we do have, some a mixed bag of experience with some researchers being really good coming to us first for any hardware considerations, and others who just go out there and just buy a big GPU honking workstation or a racked station, and without the infrastructure around it to even run it. And then they have to hand it to us and say, can you run it for us? And it's not compatible. So again, it's coming all back to trying to establish these personal connections through outreach activities and keeping a pulse on the community, I guess. That's the hard part, to hear what they need.
So the offshoot of that, how do you handle especially the requirement when it comes from a senior professor or senior person in the university and they just want it? And sometimes they need a bicycle and they're asking for a car, or vice versa. The first scenario might be easier, they want a car instead of bicycle, it's more than what they need. But when they really need a bicycle, and if they need a car, they're asking for a bicycle. How do we manage and how do you handle that?
Well, I think if they're reasonable, right? If a big shot researcher is reasonable, they're willing to listen to you at least once. And the more recently, with some new staff, we've been able to have them work with somebody we wouldn't have been able to offer up in the past, as far as a education facilitator or research facilitator. And if you can offer them a better solution with the help of a research facilitator, I think they're then willing to listen. I've had experiences in the past where I've made arrangements with faculty about for them to buy into the cluster, only to have them pull back later and say, well, I really need to justify the space I have, so I'm just going to buy my own separate cluster and stick it in that space, right? And I don't think there's anything you can do about that if they want to do it.
Yeah, but as I think Kirsten mentioned that afterwards, if they ask you to support it, that becomes
Well,
a more difficult task, which
yeah,
hinders their work only. Ultimately, they are the one who are suffering.
I agree. In fact, that same faculty member went and bought the wrong kind of network switch, and so they couldn't hook it up to the university network. And people came to me and asked me if I could fix the problem. I was like, nope. I tried to fix it before at the front end, and I can't do anything about it now.
I think related to that thing, what the administration of the individual schools, as they negotiate, at least with starting faculty, and negotiating the startup packages, that they make clear, if you need research computing capacity, you can go to the research computing group. You can make a wish list of what you want, but they channel it through there. So for starting faculty, that's often a little easier because they can kind of stop that before they have the money to do anything with it. Now for more established faculty, that's still what similar to what Aaron said. Sometimes they come after the fact, after they purchase something.
Yeah, I agree. We had a faculty member hired a year ago, and their startup package was like, look, we'll give you 4 compute nodes in the HPC. And then I worked with that faculty member to basically negotiate what that would look like. That faculty member was very worried about how much stuff would cost, and wanted to go with commodity stuff that we didn't normally work with. And I convinced him, I convinced him to go with the hardware that we normally support, but B, I also went back to the administration, says, okay, well, you guys offered him this much for his startup package, and to be compatible with what we have, I need you another $12,000. And the VPR's office authorized that, right? So I think, yeah, if you can catch them, especially with their startup packages, and sort of give them as much or more than what they were thinking they were going to get in the first place, so certainly the new faculty are very responsive to that.
So the next question I have is, when deploying or rolling out the new technology, what is the biggest pain point and hurdle? Can everyone share their experiences or thought?
I can add one, which I think it's common in most places, is you keep adding services over time. You keep upgrading your infrastructure, and it's not like you build the whole infrastructure, the whole software infrastructure at once, and make sure they are compatible, make sure they work great together. Keeping the compatibility and making sure that different elements work great in respect to each other, that's a challenge. Whenever it comes to, let's say you have a legacy file system, you have different infrastructure to deploy software. Now there is this new technology that needs a cluster-wide installation. So keeping different components compatible and have a rigorous testing before deploying it is often a challenge.
Anyone else?
I'd say sometimes the getting everyone to understand and know about the new features, things that you're rolling out, even though like everybody's automatically on a listserv and it's sent out, like unless you put like attention, like every exclamation point, like fill up the whole subject line, nobody pays attention to our emails that come. So trying to get people to recognize that there's this new thing, I think sometimes takes longer than it does to test and deploy some of this new infrastructure sometimes to get like a critical mass of people using it sometimes, because we add it to our onboarding so the new people know, but the existing like 600 plus people who have accounts that are using stuff don't know. So it's getting the outreach for those folks.
Yeah, I agree with Sean, because we had the same issue with, even Open on Demand. Like we started during the pandemic, so we couldn't have like, in-person workshops or anything. So we had it in our newsletter, like we have a bi-monthly newsletter, and then we told some of the researchers that we work with, we emailed them, but we were only having like 10-15 users using it, although we knew that, most people can take advantage of it. So yeah, I agree with you. It's hard for the existing people to use something new, like something completely new, although they will benefit more than, from it. So I agree with you.
Any other questions?
I was just going to add to the pain points. A lot of that is, so I'm working on the user services side where it's more like, related, how do you support like the new service that you're rolling out? Well, in the initial discussions, always like, how much money does it cost? And do we have enough engineering cycles to actually put this out? And how do we put it, stand it up to not disrupt the production environment? But related to that is always, the question, what is your support model? If like, a completely switch in terms of like how the researchers would interact with the system, like Open on Demand, here's a new interface. So we trying to, as we're rolling this out and, getting, researchers to test it, as Sean, described in the early phases, to kind of get feedback from them in terms of like, what would you like to see in terms of like supporting documentation or, onboarding material, so that that the service is actually being used effectively. So it's not so much necessarily a pain point, but just a consideration to kind of come full circle.
How about your experiences when you roll out a new version or a new technology, but people are not willing to start using it because they're more comfortable with the older version or older technology they were using?
So we had an experience with this when we migrated from like one cluster architecture to another. And so we we tiered things, and we slowly like took down the old service. Like we kept making it smaller. So we originally had like several hundred compute nodes that were running on this older technology. And then we kept taking some away like every few months and telling people we're removing them, and it kept getting smaller to force them to migrate their software and their stuff onto the new infrastructure and the latest technology. So we gave them like 9 months to migrate. That was one of the things that we did, and that to be able to give people enough time, since that was a huge one for them migrating from like, this was like from a different version of CentOS like to a newer version of CentOS. And along with cluster, other cluster services. So it was a big undertaking. So we gave them a long time, but we just kept making it smaller so that they kept getting less cycles on the old stuff because it was a smaller pool to choose from. That doesn't work for a lot of stuff, but in that case, that's what we did.
I think we have just 4 minutes remaining. We would like to spend some time for the last few minutes on just maybe closing remarks and summarization. Maybe we can go on the same sequence we started with. Aaron, do you want to go first?
Sure. I just want to answer. I saw a question is how do we handle switching from PBS to Slurm? Back when years ago when our budgets were really small, I switched from PBS to Slurm, and it just basically I didn't have the money to keep paying for the commercial version of PBS that we had, and I knew that Slurm was sort of the default job scheduler people use. I just made the call, and I mean I let
I
everybody
think
know
we
ahead of
cannot
time.
hear you, or is it just me?
Oh, no, it's probably my mic. Can you hear me now? No.
I hear you fine.
Yep, I hear you
Oh,
fine.
all right. Anyway, I just made the call that said that look, we're switching over. You have a month. Here's a tutorial on how to write Slurm scripts instead of PBS scripts, and I made the changeover. Tried to help as many people as I could right after that, but it was either that or not change, right? And you know, and there were angry people with me, but at the time I was the only person I had on staff who could help people, and so I was the one making the call, so I just did it and took the heat. I wouldn't say that was my preferred way of doing it by any means. As far as closing thoughts go, as far as VR is related, there are so many different aspects. I mean, I say this to a group of people working with HPC on every day who have people coming with them different applications all the time. But VR is a whole different set of problems. You know, as with HPC, it's its own set of problems. And if you go down the rabbit hole of wanting to stand up a VR technology, I would start small with a particular VR headset that you want to work with and work up from there and look for opportunities to collaborate with people. And that's kind of how we've grown over the past 4 years we started out with a HoloLens and Oculus Go and sort of worked up from there and demonstrated that I had some background knowledge in that area. And that's how we've got more collaborators on campus working together in that area.
Sean, do you have anything to add? Can you hear me?
We hear you great.
Okay. Sean, do you have anything to add?
Oh, sorry, didn't hear my name there. I guess not really. I think the open on demand stuff is a great thing that's come out of this. That's sort of like a science gateway, and I think there's a lot of other interfaces that are kind of out there that are different from open on demand that target specific domains and communities that might be of interest to some of the folks. They're going to be I think emerging over the next several years. So folks just, keep an open mind. And I think keep an eye out for, Science Gateways. The Community Institute is doing a lot of work on trying to make those things, I think, more out there and advertised and accessible. So if you check out sciencegateways.org, you can see a lot more about it, and they have a catalog of a lot of things that might be useful to some of your researchers for resources that may not be available at your institution. So you might take a look at some of those things.
Thank you. Mahmoud, do you want to have any?
Yeah, thank you. I appreciate everyone's time to add great stuff. I want to emphasize on the importance of research software engineering. We are part of research computing, helping researchers to develop software and data services. Often these are not offered in many schools. I mean, they deploy tools that are already available, but they are needs for tools that needs to be developed. For example, data warehouse, data lakes, big data platforms, and the need is growing. And I wanted to emphasize on that aspect and try to understand researchers' need for scientific software development and also data services. Thank you.
Prasad, would you like to add anything to the closing remarks?
So first, I would like to thank you and Henry for inviting me for the panel. So about open on demand, I think most people talk about it. So I'll just add that although we had a slow start because we started during the pandemic, and now we have a decent number of users who's constantly using it. And the only downside I would say about open on demand is that if you have a regular Linux user coming to you, you can sudo as them and sort of impersonate them and see what's the problem is. But when you have a GUI gateway like open on demand, you can't really do that. So that's the only downside I've seen so far. I mean, the big downside. But we're trying to work around that with using Zoom and to collaborate with the user to log in and we try different things. Other than that, I think most users are happy, and because they were asking different applications to be available on open on demand, so we're trying to add as many as possible. I mean, so thanks everybody.
Thank you, Prasad. I know we are a little bit over time, but last but not the least, Kerstin, any closing remarks on your behalf?
Yeah, I'll keep it short. I think just in summary, I think for us, it's been taking a step back and looking at the big picture. It's like before doing anything, any new service or technology, understand the users, really figure out what they want to do and figure out if the technology that they're proposing to use is the right one. And then, what kind of funds and engineering cycles do you need to do it, and how do you actually support it going, down the road to make it successful. So I think that's really what it is for us. And there are some pitfalls. I mean, it can follow up regarding connecting to sessions we have, since we using scheduled Jupyter Lab sessions, we can actually reconnect to individual running sessions that are, opened by users. And I can follow up with anyone who's interested after the session.
Thank you, Kirsten, and thank you, everyone. Back to Henry.
All right, thank you all. Let's give our panel a round of virtual applause. We very much appreciate the panel you've done. It's been really interesting, and there's been just a ton of discussion on the Zoom chat. I'm guessing it's similar over on the Slack channel as well. And I'm gonna stop the recording